All right, just take a look around you for a second. That building you're in right now, the road just outside your window, even the bridge you might have crossed on your commute, they all share something pretty huge in common. They were all brought to life by civil engineers. These are the folks who, quite literally, build the world we live in. So today, we're going to dive deep and figure out what this amazing field is all about.
I mean, seriously, have you ever just stopped and wondered how any of this stuff gets built? The scale of it all is just mind-boggling. And, it's not like it all just appears out of thin air. Nope, it's all meticulously designed, calculated down to the last detail, and constructed by a very specific group of experts.
Just picture those gigantic bridges, the ones that stretch across huge rivers, or the tunnels that literally bore right through mountains. These aren't just structures, they're the lifelines that connect us all. And yeah, they are perfect examples of what civil engineering is all about.
And it doesn't stop there. Look up. See those skyscrapers scraping the clouds, basically defying gravity? Or what about those massive, colossal dams holding back entire lakes to give us power? You guessed it, that's also civil engineering.
But it's not just about the epic, monumental stuff. It's also the things we take for granted every single day. The roads, the highways, the train tracks, these are like the arteries of our society, right? And every single one of them was carefully planned out and built by civil engineers.
Okay, so if we boil it all down, civil engineering is basically the field responsible for designing, building, and maintaining, well, everything around us. But a field this huge isn't just one monolithic thing, not at all. It's really a bunch of different specialties, and each one takes on its own unique challenges. So let's get into it and break them down.
All right, first up is structural engineering. You can kind of think of this as the heavyweight division. This is where engineers are literally in a fight against the forces of nature. We're talking gravity, wind, you name it, all to make sure our buildings and bridges stay standing.
Really, it all comes down to two words: safety and stability. A structural engineer's whole job is to figure out every single force pushing and pulling on a structure to make absolutely sure it doesn't fall down. The physics here gets pretty intense because, let's be real, the stakes are incredibly high.
So, that leads to the big question. How in the world do they keep a massive bridge from just collapsing? Well, the secret is in mastering two key ideas from physics.
Okay, so engineers have to look at a structure from two different angles. The first is called statics. This is all about things that aren't moving. So for a bridge, you've got its own immense weight pulling it down, and you've got the supports pushing it back up. To keep it from going anywhere, those forces have to be in perfect balance. Simple enough, right? But then you've got dynamics. This is where things get tricky, because it deals with moving forces, like a hurricane-force wind slamming into a skyscraper or the ground shaking like crazy during an earthquake. Engineers have to account for both scenarios, the still and the chaotic.
And all this thinking led to one of the greatest inventions in modern construction: reinforced concrete. See, concrete is a beast when you try to crush it. It's super strong. But if you try to pull it apart, it's surprisingly weak. It just cracks. Steel is the exact opposite. It has incredible strength when you pull on it. So what did engineers do? They put them together. By sticking steel bars, what we call rebar, inside the concrete, they created a super material that combines the best of both worlds. It can handle just about anything you throw at it.
Okay, so you can have the most perfectly designed, super strong building in the world, but what if the ground underneath it just gives up? Well, that's where our next specialty comes in. We're talking about the unsung hero of every project: geotechnical engineering. And this is all about what's happening under our feet.
Think about it. A structural engineer hands over these brilliant plans for a building, but if the ground can't hold it up, you've got a major problem. A disaster, really. Geotechnical engineers are the ones who dig in, literally, and analyze the soil and rock to make sure the foundation is solid. You know the Leaning Tower of Pisa? That's probably the most famous example in history of what happens when you don't pay enough attention to the ground you're building on.
And a huge part of their job happens way before a single shovel hits the dirt. They're out in the field doing tests. One common technique was called cone penetration testing. They'll bring in this big truck that pushes a special cone packed with sensors deep into the ground. As it goes down, it's sending live data about what the soil is like right back to a computer. Pretty cool, huh?
They also grab actual soil samples and take them back to the lab for some serious testing. There's one called the triaxial test. The easiest way to picture it is to imagine squeezing a tube of toothpaste from all sides at once. That's basically what they do to the soil sample. It helps them measure its shear strength,
which is just a fancy way of saying how well it's going to hold together when a massive, heavy building is sitting on top of it.
So, once they have all this data from the field and the lab, what do? They feed it all into some really powerful computer software. This lets them build a super detailed digital map of what the ground is like under the construction site. And that model is what tells them exactly how to design the foundation so the whole thing is safe and sound for decades to come.
All right, so we've got our strong buildings on solid ground. But a city is more than just buildings, right? It's a living thing. And to live, it needs to have flow. That brings us to the next couple of specialties, which are all about managing the two lifebloods of any city, water and people.
Let's start with water. Water resources engineers, these are the people we have to thank for clean water coming out of our faucets. They design the whole system, but they also handle the other side of it, getting rid of wastewater and storm runoff safely. So their projects range from huge dams and pipelines all the way down to the storm drain on the corner of your street that keeps your neighborhood from flooding when it rains. Then we've got transportation engineering, and their job is exactly what it sounds like, figuring out the best ways to move people and stuff around safely and efficiently. We're talking highways, bus and subway systems, airports, you name it. If it gets you from point A to point B, a transportation engineer probably had a hand in it.
And here's something that might surprise you. A lot of transportation engineering isn't about big construction projects. It's actually about data. Lots and lots of data. Instead of getting bogged down in heavy physics, they're running computer simulations of traffic or analyzing ridership data from the bus system. Their whole goal is to take the chaos of a morning commute and turn it into something orderly and efficient.
Okay, so we've got the structural folks, the geotechnical folks, and the flow and transit folks. But on any big project, these engineers aren't working in a vacuum. They're part of a much bigger team. So the question is, where exactly does the civil engineer fit in the grand scheme of things?
The easiest way to think about it is in three main roles. First, you have the architect. They're the visionaries, right? They dream up what the building will look and feel like, how the spaces will work. Then, they pass that vision over to the civil engineer. The engineer's job is to take that dream and make it work in the real world, to figure out the physics and the materials to make sure it's safe and stable. And finally, you have the construction manager. They take the finished plans and actually build the thing, managing the crews, the schedule, the budget, the whole on-the-ground operation.
So what does this mean for a career? Well, if we look at the numbers from the Bureau of Labor Statistics, it's pretty clear all three jobs are in demand. Construction managers tend to have the highest average salaries, and that makes sense, given all the stress of managing a live construction site. But what's really interesting is that civil engineering actually has the most job openings in the US right now. It just goes to show, as our world keeps growing, we're going to need a lot of people in all three of these roles.
So there you have it. From the highest skyscrapers down to the dirt they're built on and all the systems that make our cities tick. Civil engineering is really the backbone of modern life. And that kind of leaves us with one final big question. Our world is constantly changing, right? Cities are getting bigger, and we're facing all sorts of new challenges. So the question isn't just what's going to be built next. The real question is, what will you build?